Let us look at proposition number 26 of works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. The proposition says, the figure inscribed as above in a sphere is equal in volume to a cone whose base is a circle equal to the surface of the figure inscribed in the sphere and whose height is equal to the perpendicular drawn from the center of the sphere to one side of the polygon. So let's take it step by step. Take a great circle ABC on a sphere. Inscribe a regular polygon A, B, A prime, C prime, B prime, whose sides are multiples of 4. Draw B, B prime, subtending two sides of the polygon. Join the angular points of the polygon C, C prime, M, M prime, and so on, each of them parallel to B, B prime. Revolve the polygon above the diameter A, A prime, forming a polygonal figure. So let me just demonstrate this and then I'll remove it because the diagram becomes a little bit difficult to comprehend. So this is the polygonal figure formed when we revolve the polygon about the diameter AA prime. With apex O, construct cones whose bases are the circles on B, B prime, C, C prime, and so on as diameters perpendicular to AA prime. So we have these circles formed by the angular points of the polygon when we revolve it. So we have this circle, we have this circle, we have this circle, circle, circle. Here we can form a cone with the circle BB prime as the base and A as the apex. So very slight difference, but there is a cone here. Now we draw a cone with CC prime circle as the base, and to get the apex of this cone, we extend CB and C prime B prime and take the intersection as the apex. We extend CB, we extend C prime B prime, and we take the intersection as T, and we join OT. So here we have two cones, one B, B prime A, and the other is C, C prime T. Now, this forms a solid rhombus, and we know the characteristic of a solid rhombus. So let's proceed. So we have extended CB and C prime B prime to intersect at T. Now we revolve triangle BOC about AA prime. Now why BOC? So OB T B prime, we have one solid rhombus. Another solid rhombus is OCT C prime. Now when we subtract these two, we get triangle BOC. And this triangle BOC, we are going to revolve it. So let's revolve it, triangle BOC, and let's see how it looks like. So here a solid is being formed, what is called as a solid of revolution. Now similarly, extend MC and M prime C prime to intersect at E. So let's do that. Yes, and another cone on CC prime. So we have two cones, one on CC prime and the other on MM prime, right? And this frustum is being formed by the revolution of triangle COM. So let's rotate that as well and see how it looks like. Now, as you notice, again, a solid is being formed. Okay. So now we have revolved triangle COM about AA prime. Similarly, for the rest of the triangles, OBAB prime is a solid rhombus. Remember, O is the center of the sphere, BAB prime is a solid rhombus. The volume of solid rhombus OBAB prime is equal to a cone whose base is equal to the surface of the cone ABB prime and whose height is equal to a perpendicular from O to one of the sides, because all the sides are equal. So the distance from AB, perpendicular distance from AB to O, will be the height of the cone. Let P be equal to length of the perpendicular. Now, solid rhombus OCTC prime, OCTC prime minus the solid rhombus OBTB prime is equal to a cone whose base is equal to the surface of the frustum B prime, C and height equal to P. See, these things we have already seen in previous propositions. Again, solid rhombus OME, that is our apex of the cone, minus solid rhombus OCEC prime is equal to a cone whose base is equal to the surface of the frustum C prime M and height equal to P. And similarly for the rest. So that finally we reach the volume of solid rhombus YOY prime A prime is equal to a cone whose base is equal to the surface of the cone y prime A prime and whose height is equal to a perpendicular from O to AB, that is P. Adding all the above, we get the volume of the solid of revolution, which is equal to cone with height P and base equal to surface of the cone BAB prime plus surface of the frustum B prime C plus surface of frustum MC prime M prime and so on. And finally, plus surface of the cone Y prime A prime. If we substitute these with the actual expressions, we will get an expression which will give us the volume of the solid that is formed by the revolution of this inscribed polygon about the diameter in the sphere. So finally we can say volume of the solid of revolution is equal to a cone with height P and base equal to surface of the polygonal solid. So that is proposition number 26 of works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.